Good morning, good afternoon, and good evening. To those of you watching this, we are talking about parallel lines and transversals today. This is the beginning of Unit 2, Lesson 1. Our essential question for this unit is how do angles help identify relevant measures in real-world situations? Our objectives for this lesson is identify relationships between two lines or two planes. We also are going to be naming angle pairs formed by parallel lines and transversals. So let's get into it. First, parallel versus skew. So in parallel versus skew, parallel lines lie on the same plane and will never intersect. What that means is that the shortest distance between parallel lines are constant. So no matter the shortest distance as you go across these parallel lines, like I can choose a point here and here. This is the shortest distance. No matter where I choose, it's going to be the same distance between them. Arrows are used to indicate lines are parallel. So whenever you see arrows such as this, or you might see arrows that might look like this, okay, um, or even you might see double arrows like that, it means that those lines are parallel to each other. The notation we can see this little parallel line right here. So these two objects, line JK and line LM, are parallel with each other, and we read this as line JK is parallel to line LM. Lines that are skewed never intersect and are not coplanar. They do not lie on the same line. So we see two lines right here. We see line L and we see line M, but they're on two completely different planes. Now this does not make them parallel because parallel lines have to be coplanar. Okay? In this case, we can have one line facing a completely different direction, but since they're on different planes, they're going to be they're never going to intersect. So in this case, we would say line L and M are skew. And just like in the picture we see here, we can also have parallel planes. Okay? If these planes are parallel, then they will never intersect no matter what. We could say that this plane is going to go off in this direction infinitely. We can say it's going to go off in this direction infinitely, in this direction infinitely. And the same thing goes with down here. Plane B would go off infinitely in this direction, but the thing is, they're just going to be parallel to each other. Something like parallel universes. We might have a universe that is very similar to ours, but has some slight tweaks to it. Okay, but again, they'll never coexist with each other. So in this case, plane A and B are parallel. Now, there's no symbol. There's no indication like with lines. We can draw arrows to represent that they're going to be parallel. There's no symbols for that. Okay, but what we can do is we can almost assume based on a diagram. Okay, so here we have this image where we can say that it's either a cuboid or we can say we have two triangular prisms next to each other. We want to identify all the segments parallel to CG. So CG is here. Okay. In fact, I am going to highlight it green. Now, anything that looks like CG is going to be parallel. So we end up with a parallel line here, a parallel line here, and we end up with a parallel segment there. These four lines are parallel. The rest of the lines are not. And we can see that easily, but understand that they are not also on the same plane, some of them. So in this case, we would say segment BF and segment DH and segment AE are all parallel to CG. Now we want to identify all segments which are skewed to EH. Let's take a look at EH. Yeah. Now, understand that skew has to be on a different plane, but also um, cannot be parallel. So in this case, if it is parallel, then it technically is on the same plane. So we can look at this line here, all right? That line is skew to EH because, well, if we continue going out this way, this line, EH, is actually going to go underneath of it. And so they're never going to touch. On the flat surface of my screen and your screen, they're going to look like they touch, but in real life, they're never going to touch. We can kind of play around with this in class. We can also say that this line, all right, is never going to touch EH. And same with this line. Now we can't say AD, we can't say BC or FG. All those are going to be considered coplanar. But we can see that if we extend this way, we can extend this way. All of these are going to be somewhat, they're all going to be above the line EH. So in this case, let's write this down. We have segment AB, we have segment BD, and we have segment CD. Okay. All those segments are what we call skew to EH. Now let's take a look. Identify all planes parallel to ABD. Well, ABD is going to be this plane right here. It's the top of our cuboid. Well, the plane that is parallel to the top is going to be the base. Down below. So we're going to take this base right here, this bottom base, and we are going to name that. So we either have, we can say plane EFH. We can also say plane EFG. We can also say plane EHG, ATC. All right. So either any of these are perfectly fine. All right. We can just choose one. So honestly, ABD, we have ABD. All right. This triangle right here would be parallel to this triangle down here. And so just to be safe, C is part of this plane, and G is part of this bottom plane as well. So if we just use these three, matching with this one would be fine. So you can choose the first one. Our next subject is going to be transversals and angles. Now, this is going to be very important for you to understand, so please pay attention. And then the next lesson, we're actually going to be diving a lot deeper into this concept. So the first thing that we need to do is go over some terminology. Okay, here is our diagram. And what we can say is a line that intersects two or more lines at different points in a plane is called a transversal. So in this case, T, line T here, is a transversal because it intersects M and it intersects N, okay, at these two different points. It does not intersect their intersection point, okay? They intersect at two different points. You can also see that when these two lines and a transversal um, are present, we have 8 different angles here. Okay? Now we can have a third line come through, in which case then we have 12 angles. We could have another, and you'll see, we can have another transversal coming down this way, in which case we'll have 16 different angles. Okay? We could even have a transversal coming in through here and crossing through this um, intersection point. Then things get real crazy. Okay, so here is the terminology that we have. Interior angles. Let's identify what the interior is. Okay, so the interior is the interior of the two lines. I can write that here. So let's say interior. And so in this case, interior angles, angle pairs, we can actually, these aren't even going to be pairs, it's just going to be 4 angles. We're going to say angle 3, angle 4, angle 5, and angle 6. All 4 of these angles are called interior angles. Now, when we look at 3, when we look at 5, when we look at 4, and we look at 6, what happens is, if we look at 3 and 5, let's just look at 3 and 5, okay? We end up with this angle, and we end up with this angle. So with these 2 angles, what we can say is they're alternating the transversal. Alternating means switching sides. So 3 is over here, 5 is over here. They switch sides. Now they're on the interior of these 2 lines. So we can put this idea together and we can say these are going to be alternate interior angles. Same thing goes with 4 and 5, or 4 and 6. We can see that 4 is over here and 6 is over here. So they're alternating this transversal. They're switching sides, but they're staying on the interior of these 2 lines. Now, if we look at these 2 angles, okay, we have a couple ways that we can express this. Now, let's look at 3 and 6. We have 3 and we have 6. They are on the same side. So we can call these same side interior. We can also call them um, same side. We'll call them same by interior angles, but we can also call them consecutive. And the same thing applies to 4 and 5. Okay? They are same side or consecutive interior angles. Okay? All because these pairs right here, 3 and 5, 4 and 6, 3 and 6, 4 and 6, they all are interior angles. Now let's focus our attention to exterior. We have exterior here, and we have exterior here. Exterior means the outside. And so in that case, the outside angles are going to be our exterior angles. So we have angle 1, angle 2, angle 7, and angle 8. Now remember when we looked at alternate interior, we were talking about 4 and 6, 3 and 5. They have to alternate the transversal. They have to switch sides of the transversal. But this time, instead of in the interior, they're on the exterior. So if we start with angle 1, let's start with angle 1. We're going to say angle 1. And if we start at angle 1, well, we're going to alternate this, this transversal. So we're going to switch sides, but we're going to stay on the exterior. So we're going to go from 1 to 7. So angle 1 and angle 7. And then we have the other pair, angle 2 and angle 8. And the last pair that we have is if they're in the same position at the intersection. So we have 1 and 5. We have 1 and 5. We have 2 and 6. 2 and 6. We have 3 and 7. 3 and 7. You can see that 1 is in the top left at this intersection. 5 is in the top left. So they're in the same position. Same with 4 and 8, 2 and 6, 3 and 7. All right. And what we call this are corresponding angles. These are corresponding angles. You need to know these pairs, these names, because these names are going to be used often. I'm going to be talking about these names. These names are going to be used when we're talking about quadrilaterals and different shapes and the angle relationships between all them. So, as I mentioned before, you can have multiple transversals. They don't have to be going up and down. These, line N is a transversal to P and Q. Line L is also a transversal to P and Q. But P is a transversal to N and L, and Q is a transversal to N and L. Now we want to identify from 1 to 2, we want to identify the transversal connecting each pair of angles. So let's do that. Okay? Um, let's see this. So we have 9 and 14. We have 9 and 14. We just want to know the transversal. Okay? We just want to know this transversal. So if we have 9 and 14, our transversal for this one is the line that comes down and connects both of these segments or intersections. And so in this case, we would just say our transversal is line Q. Now, if we look at 5 and 15, 5 and 15, okay, we can say that our transversal for this one is going to be line L because 15, 5, angle 5 and angle 15, their intersections are made from L going through both of these lines. Okay, so we're going to say line L. Now let's take a look. We're going to classify the relationship between the two angles as alternate interior, alternate exterior, corresponding, or consecutive interior angles. So we're going to call them one of these. All right, so if we look at 11, 3 and 11, angle 3 and angle 11. Well, notice where they are. Are they on the interior of the two lines? This is the interior. If in this case, if this is our transversal, then we can ignore this. We don't have to look at that. We're just going to focus on these angles here. And so this is the interior of those two lines. This is the exterior. We have 3 and 11. Are both of them on the interior? No. So they're not going to be consecutive interior or alternate interior. Are they both on the exterior of P and Q? No. So we can cross that out. What we can see is that 3 is in the bottom right, 11 is in the bottom right. They are in the same position and so forth. So therefore, these are corresponding angles. Let's take a look at 6 and 3. 6 and 3. First of all, 6 and 3, our transversal is going to be line P. And we can see that they are in the interior. Now, are they alternating? Are they switching sides across line P? No. So they are staying on the same side. So that would be consecutive interior angles. Take a look at 7 and 13. 7 and 13 are here, so that tells us that line L is going to be our transversal. We can see that 7 and 13 are on the interior of these two lines, and we can also see that they are alternating. They're switching sides of our transversal. So therefore, they are alternate interior angles. Now let's take a look at 9 and 15. These we're focusing our attention to the transversal of line Q. 9 and 15 are on the exterior of lines N and L. And we can see that they are alternating different sides of our transversal. And so therefore we can say that this is going to be alternate exterior angles. Please, please, please practice. Look over these notes. Make sure that you understand all these angles, their positionings, how they relate to the transversal, and the name and how the name relates. Okay, alternating means to switch sides. Know where the interior and exterior are to the lines that the transversal are intersecting. All pow. So mahalo for listening. and make sure that you bring your completed notes for the next class. Have a wonderful evening or afternoon or whatever time it is. I'll see you in class.